I just gonna go for it. Okay, this one. Okay, broken. What? The people breaking the show.
Oh yes. Well, it's like that spot too. Like that's an awkward spot. Like I don't see that being very easy to break.
Oh, the thing. Literally, the only way to build the break this week is tugging on it. Like the hooks itself. You're this because the shoot fell like that. Right? So you're pulling on it, it's gonna stress, force it to go upwards and stuff. So I'm guessing there's some past or different slip catching stuff with the shower hose. Fucking brain and stuff.
Okay. Did you have any questions on your homework? Please make sure you finish your homework by the weekend. Make sure you finish your homework. Okay, let's start section 8.4. This is addition, subtraction, and multiplication of radicals. So before you add or subtract any radicals, then you need to make sure that the radicals are the same actually. So they should be having the same radicals or the index if you convert it to exponential function. So if you want to add, so you make sure that you convert to be of the same radical. Like for example, if you have this kind of 6 UV and then minus 4, this 6 root of 6 UV. So in this case, this radical here is actually of the same kind. So these are of the same kind. So since they are the same, then you can do what? You can factor it out, right? So you can actually factor this one out. So you can factor the 6 root of 6 UV. And then what you get inside here is what? 1 minus 1. 1 minus 1. 1 minus 1. Now, since you are able to do the addition here, then basically, finally, this is the same as what? Minus 3, right? So minus 3, 6, 3, 6. So before you add, then you check, before you add or subtract, you should check that the radicals should be of the same kind. So they should be like. Another example. Example 2. We have 5, and then the cube root of 11250 plus 7, the cube root of 270. 200. So how would you add that? Now, since the radicals are the same, they are not the same, then you need to simplify. So you need to simplify until you get the radicals which are alike, So you need to simplify 1250 and 270. So you need to get the factors of 1250 and the factors of 270. So 1250, if we divide by 2, you get what? 6 what? 625. 5, you get 125. And then 5, you get 25. Then 5, you get 5, right? So those are the factors of that. Now, the factors of 270 are what? So if we start by 3, or if we start by 2, you get what? So 1, 6, 6 or 8. And then what? What remains here is what? Is it 185? 135, sorry. 135. And then in this case, 3, can it divide by 3? Yeah. 3 for what? This one is 45. And then 3 for 50. And then also 3 for 5. 3 for 5. So here, for 1250, you have how many tools? So we have 1, 2, multiplied by how many 5s? 1, 4 5s. And then in this case, you do. Remember, it's a 5 outside there. Okay. Plus 7, the cube root of 270, we have to multiply by what? 3. How many 3s are here? 3. How many 5s are here? 1. Now, if you look at this one, you can also simplify this, right? So 5, the cube root of 2 raised to 1 multiplied by 5 raised to 3 multiplied by 5, right? So 5 raised to 3 plus 5 raised to 1 is the same as 5 raised to 1. We need to try C that can divide, that can be divided by this cube here. Plus, this is actually okay. So 7, the cube root of 2 multiplied by 3 cube multiplied by 5. Now, using the properties that we did, if we have the, let's say the root of AB, it is the same as the root of A, the root of what? So using the same rule here, then basically, when we get the cube root of this, it becomes what? 5. So we factor it out, right? So it comes out. So it is 5 multiplied by 5. The other ones will still remain, right? Because we cannot get this and this one. So we can multiply this and this to be what? Plus, this again can come out, right? The 3 can come out. Since it is getting the cube root of that, you get 7 multiplied by what? 3. The cube root of this and this is what? So finally, this is 25, the cube root of 10, plus 21, the cube root of 7. Now, since the two radicals are the same, then we can actually factor them out. So the cube root of 10, 25 plus 1. And this is equals to what? 46. The cube root of 10, 46. Thank you. So you need to follow those steps. You need it so long, at least so that you don't make any mistake when you just go slowly until you get the last one. So what I said is for you to add or to subtract, then you make sure that the radicals are alike. So they should be the same. They should be the same. Okay. Another example. If we have example 8, the sixth root of 5x minus 3, the cube root of 3. Are we able to subtract that? Are we able to subtract that? We have the same radical there. So we are not able to subtract that. So our answer is what? So if you get something like this in Newton, so you just do what? Just put that empty. So, or you just write the same thing. So you just type the same thing, a the root of that minus that. Okay. 5, the cube root of 3x cubed. If we now multiply 3, the cube root of 18x cubed. Now, when we are multiplying the roots, just the way we did, if you multiply the root of A, the root of B, it is similar to multiplying what? AB, right? As long as these roots are the same. So this is square like that. So they should be the same. So the root here should be the same for this one to be of this form. If you have the root of the cube root of, let's say, A, and the cube root of, and let's say the square root of that B, then you cannot do what? It still just remains the same. This cannot change. It cannot change unless, since we remember that, let's say the cube root of A is similar to what? A raised to what? 1 over 3, right? A raised to 1 over 3, right? Also, let's say that one raised to, let's say, square is the same as A raised to what? 1 over 2, right? A raised to 1 over 2. Then, this cube root of A, the square root of A there, yeah? The cube root of A and the square root of A is the same as A raised to 1 over 3 multiplied by what? A raised to 1 over 2. Now, since the bases are the same, then we do what to the power? We add, right? So A is similar to this. Is that correct? The cube root of A is similar to A raised to 1 over 3, which is this one. The square root of A is the same as A raised to what? 1 over 2. Now, if you multiply the two of them, then you get a raised to 1 over 3, a raised to 1 over 2. Then to simplify this, what happens? Since the bases are the same, using the rules in 5.1, then a should be 1 over 3 plus 1. 1 over 2. 1 over 3 plus 1 over 2. Which is equals to what? The LCM is 6. So it is 2 plus 1. 3. So our answer is what? A raised to 5 over 6. A raised to 5 over 6. Now, in form of, this is in form of exponent. In form of radical, what is that? So this is equals to the 6th root of what? A raised to 5. The 6th root of A raised to 5. So here, it is not the same as what? It is not the same as multiplying this and this. You see? So it is not the same as, I mean, the root of that and that. So basically, therefore, this will still remain the same as that one. Now, if we come back to our example here, then if you want to simplify this one, then in this case, we also need, because this root is the same, yeah, this root and this one are the same, just like this. So it is just like this one, okay? So it is similar to this. So therefore, we can actually multiply this and this, which is what? T. And then all of it, the cube root of what? X cube multiplied by 18x, since it is similar to this one. Yeah. Are we together? Any question after that? So since it is similar to this. Now, this will now be 15. The cube root of, we now simplify. So 3 and 18 is what? 51. 54. X raised to what? Now, x raised to 3 multiplied by x raised to. Okay. So 15, the cube root of 54. X raised to what? The bases are the same. We do what to the power? X raised to 6. And finally, we need to simplify this. Now, we can distribute the what? This root here, just like this. So 15, the cube root of 54, the cube root of x raised to 6. Now, 54, the factors of 54. We have what? 2 for what? Wait, 7. 3 for what? 9. And then 3 for. So we have 2 multiplied by 3 raised to. We have 2 multiplied by 3 raised to 3, right? Right? So here now, it will now be 15, the cube root of 2 multiplied by 3 raised to 3, the cube root of x raised to 6. X raised to 6. Now, when you come now and simplify this out of this, then what happens here? They cancel. So it will be 15 multiplied by what? How about this one? X what? X multiplied by x What remains inside is what? The cube root of. Now, finally, this is equals to 25 x squared, the cube root. Any question? So I know it's very tedious to solve this, but you need to remember section 5.1 and those properties, the properties. Any question? Now let's look at another example. Simplify to the fourth root of 8y squared minus 2 the fourth root of 12y. So how can you simplify that? So we cannot add this one, even if this is the same. So we need to simplify all this inside of the same kind. Now here, this is the same as 2. 8, the factors are what? 2 and then 1. So for 4 and then 2, right? So will it cancel? So it will not cancel. Okay, so we can write this one as 2 and then the fourth root of, let's say 2 raised to 3, y1, right? Minus, the one for 12 is what? So 2, and then the fourth root of what? We have 12 there. So 2 for what? 6, and then 2 for 3. So we have 2 raised to 2 multiplied by 3, and then y raised to what? So in this case, since this one is subtraction, then since these are not of the same kind, even if you simplify, then you don't do what? There is no answer for this, right? Because this is not similar to this. Now, if we multiply, now let's say we multiply. So this one is addition. Let's say we multiply this to the fourth root of 8y squared multiplied by -2 the fourth root of 12y cubed. So since these are not of the same kind, this one is not equals to this, right? Even if you simplify, you cannot factor out. Yeah, you cannot actually factor it out anything here because this is raised to 4. So you cannot factor out anything here. You cannot also factor out anything here to make it to be the same, of the same kind. So if they are not of the same kind, this and this, then you cannot add it or subtract it. You cannot add or subtract. Now, if these are now multiplication, if you multiply this times a multiple of this negative here, then what happens? What happens? So what you do there, you can just take -2 to the other side Yeah, so you can just bring this minus 2 to here. So it will be what? Minus 4. This 2 and minus 2 is minus 4. And then what remains inside here? 8y square, the fourth root of 12y cube. Okay. Now, since this is like AB equals to A, B, since this root is the same, then we can just combine this. We can just combine this one. So minus 4, the fourth root of 8y square multiplied by 12y cube. So what do you get? So minus 4, the fourth root of, now 8 and 12 is what? 96. And then y raised to 2, y raised to 1. And finally, this is equals to minus 4, the fourth root of 96, y raised to 1. Y raised to 5. Is this simplified completely? No. We can still simplify the radical. Yeah. Can still get the factors of this, which can be divided by the 4, and also the factors of y raised to 5. So what are the factors of 96? So 96, we have 2 for what? For what? Is it 48?
48.
Yep. 2 for 24, then 2, 12, and then 2, 6, and then 2. So how many 2s are there? So 1, 2, 3, 4, 5. So this is equals to -4, the fourth root of 2 raised to 5 multiplied by 3 multiplied by y raised to what? 4, y raised to 1. Again, we can still write this 2 raised to 5 as to be equals to 4. The fourth root of 2 raised to 4 multiplied by 2 raised to 1 multiplied by 3 multiplied by y raised to 4 multiplied by y raised to 1. And then this will now finally be minus 4. This will be what? It will come out, right? These 2 will come out. So it will be multiplied by 2. Which one again will come out? Y. So multiplied by y. And then they are the ones which remain inside. 2 raised to 1 multiplied by 3 multiplied by y. And finally, this is giving us minus 8y. The fourth root of what? 6. Any question on that? So that is how you can multiply and subtract. You can multiply and subtract. Okay, now if you are given equation like an expression like for the cube root of x plus 6, and then the cube root of plus 1. Yeah. And then you're told to simplify. You're told to simplify. So this is similar to A plus B, and then maybe something like C plus D. A plus B, C plus D. So what do you do here when you want to expand this one? This is the same as you can say A, C plus D plus B, C plus 1, B, right? So you can just use this one to multiply with this one. So it's A multiplied by C plus D plus B multiplied by C plus D. So it is similar to doing the same thing here. So you can use this to multiply. So you can say 4, the cube root of x multiplied by the cube root of x plus 1 plus 6, the cube root of x plus 1. And then you now open the brackets. So you multiply this and this, plus you multiply this and this, plus you multiply this and this, plus you multiply this one and this one. So it will be 4, the cube root of x, the cube root of x here, plus 4, the cube root of x, since this and this, plus 6, the cube root of x, plus 1. So you distribute 6. You distribute this, the 4th root of that. Then, using the properties that we just checked, if you multiply that, it is similar, right? So this and this will be 1. Which will be 4. The cube root of what? X1. Then plus. Now look at this and this one. These are similar, right? So when you factor out the root of x, the cube root of x, then that means you are adding now 4 and what? 6, which will give us 10. The cube root of x, and then plus what? 6. Are we able to? Yes. So are we able to simplify again this? This one is x squared. Is it similar to this? No. So we are not able to simplify. So we just leave it like that. Just leave it like that. Now let's come to section 8.4. And this one is the division of radicals. So how can we divide the radicals? How can we divide the radicals? So we can say divide radical expressions. Divide the radical expressions. Now, the nth root of A and the nth root of B. Be radicals, where the nth roots, where B is not equals to 0, where B is not equals to 0. This B is not equals to 0. Then the nth root of A all over B, the nth root of A all over B is similar to the nth root of A, nth roots A, nth root. So if the radical is of the same kind, then you can actually divide first, which is inside, and then you take the radical, or you can take the radical of each one of them. For example, simplify the third root of 243 u raised to 10 all over the cube root of 3u squared. 3u squared. 3u squared. Now, since the radical is the same, then we use the property like the one above. So this can be written as the cube root of 243 u raised to 10 all over 2u raised to. So we can actually simplify inside first, and then we come and apply the what? The radical. So this is equals to the cube root of 243 divided by 3 is what? 81. 81. U raised to 10, when you bring the u, which is down here, up there, it becomes what? U raised to what? U raised to 8. So this is equals to 81. The factors of 81 are 3, 4, 3, 4, and then 3. So how many 3 is there? So the cube root of 3 raised to 4. Then to simplify this in a form whereby it can be divided by 3, then it becomes what? U raised to 6, U raised to what? 2, right? U raised to 6, U raised to 2, right? Okay, so also this can be written as the cube root of 3 raised to what? 3 multiplied by 3 multiplied by u raised to 6 multiplied by u raised to 2. And finally, this one is equals to what will come out? 3. Another one is u squared. And then the cube root of any question? Any question today? Okay. Time is moving so fast. Another example. Now, if you are told to simplify, let's say 1 all over the square root of, let's say, a. The square root of a. 1 all over the square root of a. Then to simplify that, then we multiply by its conjugate. So we multiply by its conjugate. So the conjugate of the root of a is what? Is 1. So we want to make sure that the denominator is forming a perfect, something perfect that can be a number. So in that case, for this one not to have the radical, then since this is the same as 1 all over a raised to 1 over 2, now to make this one a, then we do what? We multiply both sides by what? A raised to 1 over 2 all over a raised to 1. So that is the conjugate. Now, since when you add this and this, you get what? A1 over 2, 1 over 2, you get what? 1, right? So finally, this is the same as a raised to 1 over 2. All of what? And this is equals to the square root of a all of what? A. Now, same thing applies to 1 all over the cube root of, let's say, a. 1 all over the cube root of a. Now, if you are told to simplify that, then you multiply again by the conjugate. This is similar to 1 all over a raised to what? To make this one a, or to make sure that this one, the denominator, does not have the radical, what will you multiply each one of them with? A1, 2 over what? 2/3. So what you do up here, A2 over 3, all over what? A2 all over 3. So finally, this one will be what? A2 all over 3, all over what? Since 1 over 3 plus 2 over 3 is 1, right? So A, since the bases are the same, then we add the powers. So when you add the exponent here, then it gives you 1, which is this. So finally, in terms of radical, then this one is what? The cube root of a squared all over what? A squared. Are we together?
Wait, why would you multiply?
So we want to make this to just be the exponent. We want to make it perfect, just like this one here. So to make it be perfect here, then since when we add this and this one, 2 over 3, so this and this, when we multiply, the bases are the same, right? What do you do to the power? We add. So when you add 2 over 3 plus 1 over 3, you get what? 1. So actually it's giving us a raised to 1. So what you do here, you do it here because it is similar because you can still cancel this and this. You get 1. You can still cancel this and it will still be the same. Now, since we are simplifying, then we just multiply by that value to give us, which will not give us a radical in the denominator. So you're trying to remove the radical here. So you look for a value which will make that denominator not to have the radical. Okay. So what you do here, you do it up here, and then you simplify. when you simplify, you get this. For example, why is time moving so fast today? So for example, simplify 3 all over the cube root of 15. Simplify 3 all over the cube root 15. So in that case, we want to remove the what? This article, the what? So what can we do? So this is similar to multiplying by what? The cube root of what? 15 cube square all over the cube root of 15 cube square, right? That's similar to this. Similar to what we just done here, right? Is this cube, right? So we want to make this denominator here to be what? To be 1, which is 15 cube. So what will you do to make this, all of this, to be 15 cube? So in this case, this is 15 cube raised to what? 1 over 2. And this one will be 15 cube raised to what? 2 over what? 3. This is 1 over 3, 2 over 3. It becomes what? So the denominator will be 15 cube. Then now, 3, the cube root of what? 15 cube. And that is how we say. That's how we say. Yeah, and then you can actually cancel that and that, you get what? So our answer will be 15 cube square all over what? That will be our answer. If you have 1 all over the cube root of 2, simplify. Simplify. So this will give us the root of 2 over what? Any question up to there? So you go and check the remaining part of the notes, and then when we meet on Monday, we can still go through that. Yep. So did you finish my quiz? Did you finish? Okay. You can take it over. Send it to my email.
Go to your office after your meeting.
Yeah, you come at I will look for
Okay, that works.
20. Yeah. Room just 323C. My name is just there. Yeah, 323C. Yes, just along here, and then before you get to the department. Yeah.
Probably sushi, right? It's like a-
I just bring
one
your
size.
notes if you